Let's do caption. Okay, so this week we're gonna touch on, or this today, we're gonna touch on OSI layers. This is the model that the industry used to be able to establish system communication. So every single networking devices, computing system that can be connected to the network incorporate this model, or another model would be TCP, TCP/IP model, which is a combined group of layers compared to OSI. So if you are gonna go for certification, especially in the network area, you will have to know a lot of these, but we can just go through and kind of understand a little bit. So when you connect your cable at the lowest level, you're in the layer one, which is where your signal, your electrical signal or your bits are being sent through the wire. When you create cable, you're gonna see that there's these copper little wire that's being used in the Ethernet cable. And so with that, what we would see is that it start with the physical connection. Then in the second layer, you have data link, which is where it frames your data by adding header. So every single piece of object inside the computer has some kind of information that the system used to be able to determine what kind of thing it is. If it's a file, there's a file header. If it is data, right? So think of it like before you send a package, you put it in a box, right? The post office tells you that these are the specific sizes of your box. The structure in the data link is that it's gonna frame it so that way the other system would know what kind of data that is. And it's going to put in which system is sending and which system is receiving. This ties back to the physical address of the system. So that will be the second layer. Now, when it's being routed across multiple network, it's going to go into layer three. So what we see is that layer three is mostly used for bringing your data to another network or bringing in data from another network is layer three. And in this layer, it typically would use an IP address, right? So in layer three, your data was framed in layer two. So when it moves into layer three, it actually becomes part of what we call a packet. So in a network packet, it also have header and footer. Now, let's say that when you're downloading a movie, right, it can be a very large file. Your data is going to be chunked into pieces. So let's say that I am downloading from the web server, it's going to come back in different packets. Now, it doesn't necessarily come in order. So let's say that I'm shipping a bicycle to my friend, and my friend would receive different parts of the bicycle at different times. Like today, it will be the handlebar, tomorrow, it will be the wheel. So that's kind of how the computer works, is that your data doesn't arrive sequentially and continuously. The reason why we do this is that so that way it can do that quickly. So in some cases, you're going to get the wheel before you get the handlebar. So your data sometimes would get the later part of the data, and this is what you see when you're watching video, right? It's buffering because it's still building out the next part of the video, but then there's some pieces of the video that's already arriving, right? So when it becomes a packet, the system would then be able to track like which network it's supposed to send to. So think of it like there's a label that they put on the package for the post office to know, okay, it's going to go to this zip code and which post office is supposed to receive it next. And so that's what layer three is really doing. And then through that, it's going to then do the transport. So when we talk about yesterday, like some switch is able to route, some switch is able to move your data into your network and out of the network. having that router capability, right? That's the router job, but some switch is able to do that. And then layer 4 is for transport. So this allows you to really get the data to the correct system, right? So it's really establishing communication to be able to send to specific system across different networks, right? And then in the case that we get to layer 3, this is when you have a session. You guys experience this all the time. You experience OSI layer, especially when you're using a secure website, which is a lot of them are. Like you're logging into Canvas, you're logging into your student portal, right? You connecting with the cable, your data is framed. And at the time that you're entering your username and password, once it authenticates you, it gives you a session, right? There's a session ID for that communication. So that means that the systems, the server and your computer has an agreement, right, for that communication. So if someone is intervening that and pretending to be you, it's not supposed to, doesn't mean they cannot. It's not supposed to allow them to intervene. It's like a direct communication with the two systems. And then when you get to the presentation, the data would then put things back together. We talk about the bicycle, right? At this time, it's gonna then present, here's the handlebar, here's the wheel, here's the pedal, right? Here are the parts that would put the data together. So how does it know? So each of your packet has a sequence number. So when it comes, so let's say that I received the 10th packet before the 8th packet. So when it gets to the presentation, the data would then use that sequence number in the packet and structure by sequence, packet 1 through packet 10. And with that, it's then gonna convert that and format that into something that is presentable in your system, right? And then when you see the browser loading your web page, right? It authenticates you. Now I can click bill pay and be able to process my payment. That's at the application layer. That's where it ends. And this continues over and over again every time we're using the internet, every time we're making a Wi-Fi phone call. So there's a lot of things that we utilize that would be relevant to the OSI layers. Okay. So in the first few questions, it asks you which OSI layer sends and receives bits. That's the first layer. At the electrical signal, the copper wire, when we're using Ethernet, right? And if we're using fiber optic, it will be light. But physical layer is when you are getting bits. And then in layer 3, we talk about how this is able to use an IP address. So an IP address to the system, it can be permanent, but typically it is not. It is being used for a period of time and then give that back and obtain either the same one or a different one, whichever one is available. But that IP address is being used for routing, right? So when you're looking at the IP address, we looked at that yesterday, and I talk about the host ID at the end has to be unique, right? But if you look, the 3 octet in the front, it's the same every single time, right? So for that class of IP, those first 3 octet is really like, it's used as subnet mask. So subnet mask is like your zip code. It's completely telling the system that this belongs to this network, right? Which is kind of like when you look at the zip code, you're saying, oh, that zip code belongs to this city, right? Moreno Valley. But Moreno Valley might have many zip code, and in the system, it's like that. We can subnet it to many different sub-segment of our network. And then in question 3, it asks you which OSI layer is responsible for coding data translation and code formatting. So most of our format that we use now is UTF-8. Some applications and some system uses ASCII, right? In computer science, they always talk about encoding and how encoding is important, because when you write application, you really want to make sure that you encode it for a compatible system. So when you're looking at a web application, right, or even like Word document or different type of application, it uses an encoding system so that way it can structure the data for that application. So in communication, this layer, the presentation, is when the data is actually being pieced back together, right? To be able to then show the user in the next layer. So it's prepping for the application. Any question? Yeah.
For the IPs, is 192, that's normally like personal stuff, or is it like?
Yeah, so if you see 192, and we'll talk about classes, I think tomorrow, 192, 168, right, .0 is typically in the class C address. And class C has the least number of address, but the most networks. So when you have, a smaller group of address, and then you can have many little networks. So at home, they determine that you will not have more than 254 devices.
Okay.
So that's why they're using class C for your home router. But can you use something in the other classes where you have millions of addresses? You can. So typically in an environment like our school or in an enterprise, they would use class A. And most administrator, my era and earlier, were taught to use 10 dot. It's just a preference that the industry, a lot of the people in practice that they use. Can you use 12.x.x? Yes, you can. So when you go with the lower number, the earlier classes, you just have more addresses, but less networks. So we would have a very large network with many devices. So if you're preparing for millions of devices in your organization, you use class A. By default, you just have more. Now, what happens if you run out of addresses? This is when we start subnetting, right? We manipulate the zip code, right? The subnet to add more devices to it, to maximize the number of addresses. In 2011, the world ran out of IPv4. This is why you started to see IPv6, and it took us 15 years ongoing. But most networks internally, when you do a IP config, you see that it's still using IPv4, only because the transition from IPv4 to IPv6 is slow in coming, right? I don't want to tear down my network and reconfigure everything. I wanted to add to it. So you started to see a lot of web servers having IPv6 when you follow them. But and so if you look at trace route, right? Like we saw this last time. So in command prompt, if you want to follow a domain, right? Your traffic from your computer to, like a website, you can say trace route, trace RT, and then following that. This is unable to. Let's see, Google. Okay. Maybe YouTube does it. Okay, so you see that it's still an IPv4 address, right? For Google.com, but Google has many servers. So it's going to refer to the closest server to us, right? From our network. So how does it know to point to that server? Well, it's looking at like remember we talk about source and destination. It's looking at what you're trying to reach, and it's going to say, okay, it's going to direct it to that particular server. But leaving here, this is a .1, so this is your router from the school. And then you're gonna go to another one. So you see the 10 dot here. This is a class A, right? But they subnet here. So and then you entering service provider here, right? And then you going into other networks here. And when you see, so 142 belongs to Google. Google also owns other, right? So what you see is they have some forwarder here, and then this is their server, and that's where it ends.
So it's a two-way. It goes and comes back.
Yeah, this particular command allows the system to report back. So it's kind of like you're putting a camera on your car, and every street that it crosses, it reports back to you that that's the street that it crosses. So whenever it goes into a different network, it reports back. So it takes a little bit longer than your typical, resolution with like visiting just through your browser. Okay. All right. So that kind of, so in that, you also see that that is also a protocol, right? And that's part of the TCP. In that, you would see that it goes through and it's still going through the OSI. All right. So on the next layer, we talked about the application. This is typically what you see programs like your Chrome browser, your Edge, all the browser use is at the application layer. Okay. Now, for the complete 7, when you try to memorize this, a lot of the times I typically come up with like a saying so that way I can remember, right? And then I just use the first letter for each of the layer. So people don't need to see purple alligator. And that's something that always stuck with me. One of my friends in school, she taught me that. And so when you read textbook, they probably come up with a way that you can remember it. So physical data link network transport session, presentation, and application. So for a network person, they would need to know. So when you troubleshoot, these layers actually help you, basically, right? So if I'm not connecting to the internet, right? Think about that. I would check the cable, that's at the physical. I would see, and so the issue might be happening when you interface the system. Like I open the browser and it says cannot find the website, right? It's not check your connection. There's an error. Okay. Then I would go through, check my cable, right, to see if there's a link signal. If it is, right, I would go through and I would check, I would ping, I would see if I have an IP address in the network. If I do, then I would move on for each layer and each layer. And that's how you're able to fix a lot of the problems in the network. Okay. Any question regarding OSI? So for the quiz in this class, it might refer to some of the questions that you see in the assignments. If you are going for the job or if you're going for the certification, you have to know these layers. So in the world of networking, there are 2 forms of connection. One sounds kind of strange, is connectionless, right? And 2 is connection-oriented session. So in the connection-oriented section, the host, which are your computer, your communication system, it has to be able to have an agreement. It's kind of like you and I agree that we're gonna exchange some homework information, right? So I first tell you that, hey, I'm gonna give you question 1 through 5, and you're gonna give me questions 6 through 10. Okay. And we both have that agreement. So what these systems have to do is they are going to establish a connection rule or a set of rules to be able to communicate and then exchange data. And so typically when you are visiting the web, it is just a synchronization data process. So that means that I request Google to give me data, right? So that system agrees to synchronize the data with my system. Okay. And so the data is then going to move from that server through the network into my system and present it to me through the application. So there has to be an agreement and an acceptance. And this is purposely created so that way you have reliability communication for your networks. Okay. All right, let's move 6 down. So in the connectionless oriented, so some system have rules where it doesn't need confirmation that it's connected, right? So that means that it can be connecting now or it can be connecting later, then the data will just arrive as it does. Okay. So in some cases, that's what you're gonna see. It's like my example would be that you can ship a package and you can require someone to sign for it. So they have to be home and be able to acknowledge that that package is received, right? So that's like connection oriented. But in the case of connectionless, you can just tell UPS to be like, oh, I want to pay the cheapest rate, and you can ship it train, plane, bicycle. I don't care as long as it gets there, right? So eventually your package will get there, and sometime it could be 2 weeks, sometime it could be 10 days, or sometime it could be within the week, right? So in some cases, you have services that would use that kind of environment, and some protocol would use connectionless. So it doesn't need that acknowledgement and confirmation. Now in systems, flow control is important, right? It really is a way to be able to have a certain amount of data that it's being sent across. We don't want things to be congested. So let's think about it this way. If you have to send a very large amount of data, right, that's going to take up a lot of bandwidth. So if we don't regulate that, then if we have a lot of downloads and upload with very large amount of data at once, it's going to slow down our networks. So flow control really allows us to really look at like whether our system is going to handle it, because before the data move, it goes into RAM. And from RAM, that's when it's going to move. So your switch's router has RAM, and you don't want buffer overflow. So in that, what they do is for each packet, they're going to regulate how much data. Remember what I said? It's going to chunk it up into, it's like, you don't want to ship a humongous box because it's going to cost you a ton of money, right? You want to be able to take things apart and put it in the smaller box. And so that way you can just ship it, and it's more affordable that way. And it's more accepting in most shipping company, and the system does that, right? So we want to be able to regulate it so that way you don't have buffer overflow. It's not overloading that system, right? And when it's being received or when it's sent, that's basically it. Okay, so the router, we talk about layer 3. The switch is when it looks at layer 2, right? So remember what I said, the router gets you to the exit, the switch gets you to the street of your house, right? So it really pinpoint which system in that local area network, right? Based on the information. So with that, it uses data link, and data link has like a way for it to detect the physical address, right, with source and destination address. So the receiving system, where that is in the network area. It's like which house it is on that street. That's what the switch does. Now, some switch is able to handle both, right? It's able to route and also switch. So you see a lot of that for call center. So they use that for like phone connections, voice over IP, that kind of stuff, layer 4, layer 5 switches. Okay, so when we're looking at the actual devices, which devices are really functioning at the physical layer? Your network adapter, your network interface card, because it's received signal bits by bits. And then you have transceivers. Some old school system has transceivers, some industrial system has transceivers. Repeaters, basically repeaters just take that signal and regenerate it, right? Like if it's 1, then it's regenerate the 1. If it's 0, it's regenerating that 0. And then your hubs. So hubs are different than switch in that hubs just sends. The switch actually checks to see if it sends correctly, if it's received. And if there's an error, so let's say that I'm trying to send to system number 4, but it shuts off, right? The switch is gonna reattempt that because it's gonna see that the system number 4 did not receive it. And then once if it gets an error again, then it times out, then it would give you that notification. Yes.
Repeaters separate from hubs.
Yeah, so repeaters just take your signal and repeats it. Where the hub, right, sends it to, so if I'm using a hub for the 4 system in the front, the hub would take the information, let's say from system A, system number 1, and send and forward it to everybody. So it's kind of like I'm trying to send a package to someone on a certain street. So what the hub does is it's like, who is this package belong to on the street, right? And then it doesn't really gives you like, so if someone doesn't take that package, it's gonna be like, oh well, right? But the switch, what it does is it actually knows that certain system is supposed to receive it. If it doesn't, if it's shut off or something happens, then it's going to retry, right? So hub is not smart. Switch is smarter. Even the unmanaged switch. And they look kind of alike for the smaller switches in the hub. Okay, which layer of the OSI does the router operate? We mentioned that it's at layer 3, so therefore IP address, both version 4 and 6 exist in layer 3. It's used for layer 3, and IP is connectionless oriented. So IP is just used purely for addressing, where TCP is really used for connection. So they go together, right? Use an address to really find the connection, establish that connection, and then so that's why you have some protocols that are used for certain things. Okay. 11 asks you, how does data transmit across the network? I have all kinds of grammatical error on these. So what it does is in the packet that you're looking at, and I'm going to show you what that visually looks like. The data is wrapped with protocol information. So every single thing that we use with the computer that relates to network communication has some form of protocol. From the time that you use ping command, like, or trace route, like what you saw earlier, it has a protocol. And remember, protocols are rules for the system to follow for that communication and for that service. So the data is then, think of it like when you're shipping a certain product, you want to put it in the right box and maybe bubble wrap it or whatever, package it the right way. And you want to, like, let's say I need to ship something that's fragile, that can break, right? I would have that label. And on that label would represent whatever product that I might, so handle with care, fragile, right? Things like that. So the protocol really it correlates with the data that's being communicated for each of the layer in the OSI. So if we're using web pages like HTTP, HTTPS, right? It's wrapped with that, so we know that it is web content that's need to be formatted and presented through HTML. So I'm going to show you have this too, right? There's a thing called network sniffer, right? The formal name is protocol analyzer. So every packet that's sent across the network has protocols tied to it to kind of tie back to that. And the one that we're using here is Wireshark, and it is very, very common in the IT and security world, right? You can download this app. It's free. So when you're sitting at the airport and you're connecting to public Wi-Fi, I can see exactly what you're doing by using something like this, right? So when you opened up the app, you see how it tells me that I have this interface, which is my Ethernet adapter. You can also select other adapter that you want to use, even for Bluetooth. So I'm going to use the default one, and I'm going to click the fin to start. So there you go, right? Everything on the network is sniffing, right? From the time that the switches pick up to the router sending everybody on this segment, right? Now, if I want to create some form of packets, right? I can just open up my browser. Let's find some kind of HTTP website because they're not that common anymore to really, and then I keep refreshing. So, and then it's going to sniff that out eventually. And they're color coded, right? So you see where that's coming from, where that's going to, what protocol. So I'm going to pause it so you can see, right? See? Everything has protocol ties to it, right? And then if I want to explore certain protocol, I can also filter, right? HTTP. There you go. Right? That's the website I went to. Okay. Now you can see, now I'm opening up the packet. Remember we talked about the frame? It shows that here, right? So when it structured that, it put a timestamp on when that data is really framed, right? The size of your data, you know, the interface that's used. Remember we, like so the ports are like the window or door that the system used to pass some kind of communication information. So 80 is always HTTP, HTTPS is 443 or 444. Some administrator, they would use uncommon port, but by default, you're gonna see that. And you would see, there's also your physical address. You can tell that that's a Cisco, possibly a switch that's passing that. Okay. So now down here, right, I do see some information like definitely Chrome. And then there's like tools that people use in security that can take your packet and modify it, right? Things like that. So when they sniff out your traffic, so this is part of like in ethical hacking, we call this like the discovery process, where we trying to understand like what's being communicated. And then we started to kind of drill down on like the target. So you can scan everybody and then you can identify like who the target would be and then go from there. Okay. So this is how we sniff out network communication. So I can see everything if I'm attaching myself to the network. And public Wi-Fi, you just add yourself to it, right? And then scan. Okay. So don't use public Wi-Fi because they're watching you. All right. So today we're gonna make the coaxial on your typical cable that they run for your cable TV, right? The ones that you're making today is gonna be the thick net. The thin net is the older cable. So if you have an older TV cable TV, you would see the coating on the outside is not as thick, but the true difference is going to be your core, where that needle is going to be. Restricted. It's going to make this today. So as you make your cable, you open up. So this is a thick net, right? You're going to see that it is insulated with foil. And the purpose of the foil, it does a couple of things. It keeps it cool because copper can be very hot. And also, it also can reduce the noise, which is, in electronics, we would see that there's a lot of noise leakage. And you see this little fibrous hair, right? That is surrounding that, right? So in thicknet, you cut it twice. You cut the outer coating off by doing one twist, and then you twist it a couple of times to get it to the needle. Okay. So you make that today, and then you brush your hair back. So you would see that the diameter inside the thicknet, the needle is a thicker diameter, and there's also like a plastic core that surrounds it on the inside, and that is the diameter is bigger compared to the thin net, which is a long time ago. It also used slightly different connector. So the connector we're using is going to be the RG6. So the RG6, and it has this rubber booting. So one end is where you screw in the cable into your wall or your cable box. The other end is the butt of it. So you just insert it and push it down. Yeah, you have it, but it's not done. So you have to compress it. So when you compress it, this rubber boot compress together, and then it stays together. Do not cut off the hair. The hair, you can trim it off a little bit. If you look at your cable that they run, typically this hangs out. It keeps it in place. It might not look very clean, but so you want this needle to be flush at the mouth. A little bit under is okay. So when you use the compression, I'll show this again. The tool looks like this, and you put the needle, the hole into your hole here. It's too far back. And they got this in the back. I get full set. Okay. So sometimes you have to do it again. So you put it into the compression tool, and it's not very hard. You just press it down. Yeah. It's bad because I didn't have it see properly. But the point is that it compressed this down, and then you trim the top. And that's really how the coaxial is, and you do the other end. And it takes like 2 minutes, okay? So they charge you $50 to come out to your house to run a cable. They come in and they look from the garage to that, maybe a few meters, and then they go and they make the cable in the van, they plug it in, and that's $50, right? So you can do it. And then if you mess up, right, you just basically take the wire cutter. So once you compress, you cannot use it again, right?
So if it's too long,
Huh?
if the cable is too long, suppose it runs from the closet and all wraps around.
So if you cut it shorter, you just need to put the connector on the other end that you shorten and then compress it. This tool is about $10-15, and a bag of these is like $40-50, but you can get like a bag of a few, and they come in blue, black, right? So on the thin net, it's slightly different. It looks like this, and this is a female one. So this is the one that has a needle, and you put it into the wall or your cable box. Where sometimes you make a male one, which is the opposite. So you just use a different connector. But so in the sense where if you're using thin net, it's an RG59, which is the other grade. And they look kind of the same, but just make sure you get the right connector. So the current one that you're using, RG6 and thick net.
So before you go anywhere,
Mhm.
so we have these so-called fiber optics. We talked about them yesterday. But the one that is going to connect to the modem is going to be a coaxial cable.
Yeah, so fiber optic has different type. You have, and the way you determine that is the connector. The consumer fiber optic, you have these strands, right? And you use it mostly for audio or some kind of more higher end definition type of system. But the way that fiber optic is installed for communication is it has a termination box, and these wires terminate to that box. And from that box, they will patch it out to the Ethernet network. Yeah, too bad that this room doesn't have it. When I taught in the other room, we have a box there. So you would see a patch panel with the Ethernet cable connecting to it, and the signal from fiber optic would drive to that box. So when they dig a line, like Frontier comes and dig a line to your house, they're gonna run that to a DMARC, which is a box to your garage. And in that DMARC, it's gonna continue your signal from fiber optic to the rest of your household, which is gonna be Ethernet. So basically, you're taking a super sport car, and then when it gets to your house, you're still gonna drill it down to, you're still gonna get very high speed internet, but true fiber optic is very, very fast, right? So we use Ethernet network inside our home. So that's kind of like super sport car, but you're driving it at 60 miles per hour. Ultimately, when it comes back to the local area network. So they would bring fiber optic to the backbone where all the switches and the routers are, because that's where the super speed needs to be. And then everybody else is on Ethernet. Okay, so the connector that you're using today, I showed you this a little bit last time. It looks like the phone connector. Okay, so when you're making the cable today, the clip, which is your tail, the clip is always on the bottom. Okay, a lot of students, they flip it up and then they insert, I make them cut it off and do it again. So this is an RJ45. Okay, there is a line across the connector. That line is used, it's pressed down to the cable to hold it in place. So once you crimp it, it's that crimp line is going to press down on the plastic coat of your cable. Okay. Now, a good cable is where everything is flush and that line is on the plastic cover. If you make a cable with a bunch of copper hanging out, I mean, it still works sometimes, but I can just yank your connector. If you pull the cable really hard, right, it's just going to fall off. Okay, so this is an RJ45 that you're using for Ethernet cable. So you guys know what the telephone line use? It's RJ11, the smaller ones. It also has a little clip, the tail. That's an RJ11 and smaller cable. Okay, so the Ethernet cable that you typically see is unshielded twisted pair, right? So this is your Ethernet. They come in all different color. I like a network that is color coded. So as you can see, this segment is yellow cable. If you look at your computer connecting to the wall, right? Now, how do we know if it is unshielded or shielded? So UTP stands for unshielded twisted pair, right? For a cable that is unshielded, when you strip it, I only need to take the plastic off. So don't run it. In the video, a lot of the technician, they use a duller, a stripper that is more dull. So they run it a couple of times. These are very sharp because they're fairly new. You just need to run it once, rotate it once, okay? So when you strip it, basically put it into the alligator mouth, right? Like about almost an inch, and then rotate it, it's gonna take off your plastic cup like that, right? Now, if you look, they are twisted, right? These are twisted copper pair. You have to untwist them, and then you need to arrange them by the color when you insert them into the connector. So for the UTP, there's no foil underneath when you take the plastic off. When you use STP, which is typically being used in an area where you have a lot of cables and you want less like interference, then they would buy an STP. Kind of like the coaxial, how it has the foil inside, right? The Ethernet cable, if it has the shielded twisted pair, it has foil piece inside. They cost a little bit more, right? Because it's just, more to produce it. But they're used the same way. Now, if you have lots and lots of cable together, likely that you have interference, just like all electrical signal. So now crossover cable are used for computer to computer, switch to switch, right? if you have a router that uses Ethernet, and just now we don't anymore, we use like fiber optic, but crossover are used for the same type of device, computer connected to computer. So if I take my laptop and I'm connecting to my desktop and I'm using an Ethernet cable, it has to be a crossover. It's not your typical Ethernet cable that you buy. The typical Ethernet cable that you buy is a straight through cable. The arrangement of your copper inside the connector is different, okay? So you have an option to do that today, and I'm going to show you how the signal reads when you do the test. So the arrangement on one end is different than the other end for the crossover. And then for the straight through, they're exactly the same. So when you take a look at the Ethernet cable that you buy from the store, if you look at the connector, the arrangement of the color, one is the same as the other, okay? And you would use the straight through to connect a computer to a switch, right? A computer to your wireless router that has the Ethernet connection, because they're different devices. Yeah.
What would be the practical application of connecting two computers?
Oh, to exchange data. I don't want to connect my computers to the wireless network, for example. Let's say I'm traveling and I have two laptops, but I don't have wireless connection for my laptop to connect and my desktop or another laptop to connect, or I don't want to. Yeah, you can just connect. Okay. So in the notes, it's going to give you a lot of information about, let me view. So we talk about coaxial already, twisted pair, right? Now, I wanted to touch base on the speed, right? So from the olden days up until now, so when you're using Ethernet, I already know that you are at 1,000 megabit per second. We say megabit per second because it's not data, it's transfer rate. But when we deal with data, you say megabyte, right? And one byte is 8 bits difference, right? So whenever that you see an Ethernet cable in the standard, it will be 1,000 base TX. Whenever you see the TX, that's a twisted pair. That's an Ethernet technology, right? But Ethernet is also rated a little bit different. So that's a UTP. And the speed that this number right here represents the rate, the transfer rate. Okay. So if you're looking at the old Ethernet cable, the old technology for twisted pair, up until now, it was at 10 megabit per second before. Now it's, and then 100, now it's at 1,000. That's where we're at, right? So a straight through cable, you can see that it is parallel in the copper signal, right? Like 1 to 1, 2 to 2, you know. So the arrangement, you're going to see that there's some parallel in these wires. Where the crossover, the one, it crosses, right? So you see, you trace it 1 to 3, right? 2 to 6, and then, you know, and so you follow the color coding and do that. So one end is going to be different than the other end. That's how the copper crosses. So that's, you know, and your computer is really designed to send signal this way, computer to computer. Okay. This is standard B and standard A. And A+ asks about this also. Okay. Now, for the Ethernet cable, they also have category. I think the industry now, most of them use Cat6. Cat6 is very close to Cat5e, but many networks still have Cat5e. It's just the frequency is different. So if you're looking at Cat6, it is a little bit faster in performance because it's double in the frequency as it transmit across the copper compared to the older Ethernet cable. So if you buy Ethernet cable to make, like I want to say 10 years ago, you're going to see Cat5e. But if you look on Amazon today, you're going to see Cat6, and I think they're releasing Cat7. So Cat6 is probably the most common, and it's cheaper than some of the newer ones, because performance and also like just supply and demand, right? And so if you install networks today and run cable, you typically would have Cat 6, category 6. Now, they all have a maximum distance, which is 100 meters. This is why we don't run Ethernet from one floor to the next, is because the distance. And the farther you are from the source, the less signal you receive because of deterioration and also interference. Okay, so that's why they're called twisted pair. Now, you don't have to strip them down like this, like electrical wire, right? You just untwist them and arrange the color. And RJ stands for registered jack. Any question? So this is the phone, which is RJ11, and your Ethernet, which is RJ45. So today, right, when you make your cable, if you do the straight through, the arrangement will be, white, orange, orange, white, blue, green, white, brown, brown, right? And then you insert it. And these are push through connectors, so you can push it all the way through and then you can trim it. They're pushed through. Okay. Which is easier to use. Okay. Let's talk about fiber optic. I think when we mentioned that fiber optic is light, it uses light source to transmit signal, definitely faster because of light speed. Now different fiber type uses different light source. Some of them use laser and some of them use LED. Now the industrial fiber, as you see with the big roll, when they roll them out in the truck, right, they would slice them and they would terminate them or connect them to a certain area, and it would go down to the manhole, underground, and all the way through. So manholes are owned by communication company. You would think that it's more like sewer based, but a lot of them are very clean. Sometimes they cover this, but near freeway entrances, right, like on ramp, you would typically see like they put mulch or things cover, but a lot of the times they have a cover, and under that cover is a way that you can get down for a lot of maintenance for communication company. When you go down there, it's a ladder that you go down, and you would see like switches and different things, like bulk cables, right, coaxial, and if they're using copper and fiber that's running through until, because they own certain section of the town in communication setup. So when you're using fiber optic, which is what you see today, the advantage is that it's very fast, it is reliable, there's less interference, or it's immune to it, and it's consistent. So it's definitely something that you can use in the backbone of the network and also throughout your network. If you buy a new home, likely that you would have fiber drop to your street, or at least to the home. The disadvantage of this is still the cost of it is still generally high, but I think now the supplies are there, and there's a drive for fiber across the United States, right? Is it really difficult to install? No. In my opinion, if you practice, right, splicing fiber, you have the tools and the technology. If you install fiber 15, 20 years ago, yes, it's very hard because you just actually don't have the tool to do it accurately. So you have to have a lot of experience. So it's not too difficult to install. You can actually get a student kit, the practice kit on Amazon, and be able to learn how to do it. So the benefit also for fiber is going to be your distance, right? So let's say tomorrow you win the lottery, that big jackpot, that's, I don't know if somebody cashed in on it, like 500 million or something. That's like the probability of winning that is very small, but you never know. And you decided that you're going to buy an island to live on, right? And then when you go out to build your home and you're like, wait, I need to have internet. So what you can do is you can get a company to run fiber into the ocean to your island, right? Which is what you see with a lot of the resorts that is remote, like if you're looking at the Bahamas and so on. So it will go up to 3,000 feet, right? And you can terminate it. So typically they would have a tunnel, and inside that tunnel is where your cable, right? So now let's look at some notes information so you can see. So SMF stands for single mode fiber optic, compared to MMF is multi-mode fiber optic, right? So in this, for SMF, your single mode, it is glass fiber. So inside that you have a glass core and it uses LED and laser. And so the insulation of this is because of glass, you have to splice it straight because even at a whole diagonal, because the light would bounce, right? So just imagine that if you don't cut it at a straight slice, you angle it, when the light source hits it, it's gonna bounce back. So you lose signal that way. And so it is transfer 50 times further than your multi-mode. So if you want to go the distance, you use a single mode. Okay. If you want to use multi-mode, right? You can do multi-mode like I said, in tall-rise buildings across the campuses, like at the university or downtown. It is easier to install and it looks something like this. The strands are tiny. And then if you open up the multi-mode on the inside and zoom in on it, it looks like that. Okay. So the core would have multi-light sources that is going to generate the signal, but then you are going to have less of a distance compared to single mode. Okay. So now you know the difference. Now, so earlier John asked there are different types of fiber, but what you see is that when you go and buy fiber, you are going to see connectors. Okay. And so they sometimes look like this, and you typically see this for like audio equipment, like for if you have like home theater or DJ equipment or stage equipment, you typically see something like this, right? This is a BNC, and the old coax also use BNC. And then you might buy fiber strands like at the store like Walmart or Best Buy. You would see SE connector like this. And it is typically square with like a little button inside, almost look like. There's a way that you have to use like a machine to install this connector. Typically now they automate this, right? You have a system that humans don't do this because it's just better in cost for production. But you can also buy connector to do that. I actually have equipment to do that, right? And I did a lab long ago with my former students on that. A little harder to work with. But yeah, so they sell equipment for you to also set the connector and test the connector. And then you also see something like this, which is your MTRJ or with the LC. And this is newer. So when you're using gigabit Ethernet, right, it's definitely way faster. That's what they sell. And then you also have something like this. So will you need to know the difference unless you're gonna go into fiber technology, fiber optic technology, or networking with fiber? Then you need to know that. And so as I promised you, right? Fiber technician makes a lot of money. Do I have to get a degree to do that, right? You should just get a certification, but typically if you work for Verizon, Spectrum, Charter, they certify you. But it's good to have like background in networking to apply for those jobs. And you can search certification for fiber optic, which is called ETA. And you will find their website. You can buy their book to study about cabling. I think it's fairly affordable and it tells you like what you need to do. So there's 75 questions on the exam. The passing score is 75%. It's 2 hours test and it's good for 4 years. So you don't have to recertify because by that time technology changed. And it's $150, $55, which is much cheaper than some of the other tech certification. Um, I used to work for a school that taught this, but anyway, so you know, and there are also other type of certification on the website that you can see. So if you want to be a technician in fiber optic, like data cabling installers, your DCI here, compared that to your ETA fiber optic. Yes.
So that's a TA. Their certifications are recognized.
Yes, it's accredited. Hmm. But when you apply, let's say that you get this, right, and you apply for Verizon, which is very common. I think the base rate for Verizon technician with little experience is $50 an hour, and it can go to $150 an hour, which is not bad. Or if you work for Spectrum, they certify you because
Frontier.
even if you, yeah, Frontier, even if you certify here, right, this is industry recognized, but they also, it's vendor recognized. So you have to go through their training and they talk about safety and their equipment and all of that. So once you go through that process, then they would send you to jobs. And you see them all the time. Like when I drive to work or leaving work, sometime at night, sometime during the day. They do night because that's when like those system can be down or that segment for maintenance. But you can see other certification on that page and read the information there. And you know, and from the website, they actually point you to like the resources that you can use to prepare for it. Okay? Any question?
Free retake.
Okay, so for 18, we talk about single mode fiber is for fast speed, and multi-mode fiber is used for long distance. I had it around the other earlier, up to 3,000 feet. So the island that you are gonna own when you win the lotto, and you can invite me there, then that will be your multi-mode.
So I thought between buildings would be the single mode.
Yeah, single mode is between buildings. And multi-mode is, you can use multi-mode, I guess, across the buildings too, but it will be more efficient if you use single mode, right? But if you have access to multi-mode for everything, then multi-mode it is. So that's kind of short today. I kind of condense it. Um, this chapter in the regular class is much longer because it talks about like other communication technology, but you can expand it and look at like the panel. So fiber distribution panel would look something like this. That's what I described earlier. And typically they would house it in a box so that way people can't just pull it. So you would have the connector going into an Ethernet patch panel would have like the Ethernet connection point. Yes.
This may sound a little bit stupid, but the first class you taught, the wires were color coded. Last week, were color coded. So with this over here, if you send the technician and the wires are kind of messed up. How do you figure out which one is wrong? I mean, do they have?
Yeah, they have a signal detector. They have tools for you to do this. There are specialized company that make tools for you to be able to do that. So like splicing tool, like to cut fiber, we splice it. Because if you're using glass-based fiber, you have, like I said, you have to cut it straight. So you have to use a proper tool. You can't just use wire cutter. Right? Wire cutter would just ruin your cable, and fiber can be expensive, so you don't want to damage it, right? And so you would have like it can go into a rack, but it can go into a box, and then you connect it like that. Okay. I was pushing for NBC to do a certificate, like I would write a certificate for fiber optic technician, and use a grant to be able to accommodate it. I talked about it before. Um, but I don't know. There's like different perspective on, whether we should have it because certificates don't have enrollment compared to even for something like this that's highly demanded, right? Compared to associate degree because state funded formula is typically like for a degree that you can transfer and stuff like that. Yeah.
So, say you're trying to get into like Verizon or Frontier to get into this first, like, you would say you would need Network Plus to start off.
You don't have to have Network Plus. If you want to be a field cabling technician, get the ETA, right? Like pay $150, $5, get certified. But if you take the classes and have networking background or having Network Plus, it's a plus. It's a leverage, right? Like you when they see that, or if you have an associate degree in electronics or something like that, that's helpful. But because a lot of the technician, they don't require you to have too much. A lot of them require experience. If you don't have the experience, you have the knowledge. Yeah, get the ETA certification. Yeah, and they have site that they test, so you can look at like where they actually offer the test, and there's different ones for fiber optic, right? And then you can use their resources. They have books for you to buy. And also Amazon also have other sources. The internet have other sources too, but I would use their stuff to study for their certification. Yeah.
Which certifications you're.
If you want to be an installer, get the installer FOI, this one. They're all $155. It's very affordable nowadays. Yes. So if you do the broadband technician, this is a little bit different where you have like reflectometer, you using different tools. So if you want this, right, this is specifically for broadband, and broadband typically is like business oriented areas. And a lot of them are, technicians, they go out and they travel with the team and they do, and you go work with the boxes and the equipment. You don't install in residential. You can do residential stuff by doing the data cabling one. That's a residential one. Okay, I did a lot of field technician work, including networking. All my jobs are business to business, B2B, because residential is questionable. Everybody's home is a little bit different. So, including mine, like people have to like pets when they come, right? So, anyway, so I'm just saying, but some of my former students are currently working at Spectrum. Some of them left Spectrum. That's how they started. They did data installer, business to business or residential. And then one of them ended up at their data center now. So if that's what you want, and they contract you. So when they dispatch you, you get already some money. And then when you do the work, they pay you by the hour, right? Charter just picked up Spectrum. So now they own Spectrum. And then if you work for Frontier too, right? But depending on like who buys who, and you can work for AT&T, Verizon, so they have their own line, right, for mobile based networks, but still, it's still fiber to the cell tower. Yeah. You can probably find places like trade schools that offer this, and they're not cheap. If it was me, I just buy the material and I study. I've seen students that have done it successfully on their own. If the most That's the most affordable way. And you can buy, home kits or I've seen Amazon and other websites sells them and you can learn it. And cable, a lot of the stuff is available in stores. Um, but yeah, the benefit of going through those trade school is sometimes they can connect you to the jobs, but you're still gonna have to hunt job. There's no guarantee that they're gonna place you anyway. So I've worked for private colleges and university for a long time, and I mean the employment rate is just typical compared to that in public school, so they have like certain people that would supposedly help you, but you still should help yourself to get the work. But yeah, this has been very kind of like the thing to go to if you want this specific area. Okay, any other questions? And you can search, yeah, John.
Yeah, the thing is, I don't know what to take this college to start something called a job fair. Some kids or students, once they get their associate's degree, like in nursing, they work with the instructor, who has connections with.
Yeah, but because the accreditation for nursing requires that they have to put in so many field hours to do that. And in technology, a lot of them don't require that. Like just like cosmetology, they have to put, or counseling, right? That's why like you have to go through the program and you have to fulfill the hours. Um, yeah, unfortunately, technology doesn't have that requirement, like, have incorporated internship. We do have the apprenticeship part of it. But yeah, like I would, if you like this, right, I would encourage you to pursue something like this. And it's always a good backup option if you want, that career. And you can find things, like fiber and type today. Technician job, Riverside. In a lot of like newly developed area, especially like in our city here in Moreno Valley, because they have new homes and new businesses and expansion of the city, you see a lot of this requirement, right? Yeah, you see them all the time. Yeah, but Google is going to give me some fee. Now, like the $20-$30, those are the data cabling ones, right? But fiber optic can make a lot more money than 20 to 30 bucks because $20 to $30 an hour is not very much these days. Okay, let's stop and